Okay, good evening, everyone. Thank you for coming for this session. I will be talking really about very complicated things, but I promise you I will show very little of the Java code. So nothing complicated. I will try to show these complicated things through my own perception of these, rather than showing you internals, because it will take a really long period of time. So basically, I would be sharing with you my experience in a totally different world, which is quite interesting. So this is agenda on what I will be talking today. So first is why robots. We will be talking today about robots. My story, how I get to this robot world. What you should do if you want to get there, and how. So let's start. But first, I'll introduce myself. So my name is Andriy Petlovanyy. I am Senior Solution Architect at Global Logic. Today is precisely 4 months, exactly today. So it's my kind of anniversary, small. I have been working as a head of software in Shadow Robot company, which is based in United Kingdom. And also in general, for more than 4 years. And in general, in IT, I am for more than 18 years. Also, I am co-founder of the ROS Ukraine robotics community. We will be talking about this community later in the speech. But first of all, what I am doing at Global Logic, shortly. So at Global Logic, we have an expertise, deep expertise in the medical devices. Different medical devices, from the one which are helping medical staff to observe you, to assist them during some kind of interaction with patient, to the things which are variable by patient, and which basically are helping people to have better lives. So if I would like to summarize what I am doing in my current work, is basically I'm robotizing humans to make their life better. So my previous job at Shadow Robot company was around this product which you can see here, which is Shadow Robot Dexterous Hand. So this is like the best in the world replica of the human hand done as a robot, as a machine. So it has 20 motors. It replicates almost all human hand movements. And as you can see here, my ex-colleague staying with one of our customers' robot, which is Robonaut, which is currently flying in the International Space Station. And yeah, so basically NASA bought our hand to evaluate it for different internal programs. And to summarize my work in the Shadow Robot, I try to humanize robots. So as you can see, it's a two pieces of one puzzle. So something to do with the humans and robots. So why robots? But before I started, so I promise you to everyone who will survive till the demo would be cool. So I will try to, we basically will try to use power of Java to destroy Lviv National Gallery. So it will be in real time. You will see how it just get destroyed using a few lines of Java code. So if you survive till the time, so you will see it like in real time. Okay, good. So basically, why robots? If you look into the Wikipedia page of the Industry 4.0, by the way, who has heard about Industry 4.0? What is it? Has anyone heard about Industry 4.0? Can you please raise your hands? 1 person, 2 people? Okay, good. So I will explain it in my next few slides. So Industry 1.0 is then humans started to use steam, which started to move different machinery. So their first factories appeared, which were powered not by humans or animals, but were powered by steam. So heat were producing steam, and these factories were doing some useful job. This was Industry 1.0. It was like big industrial revolution of the time. So the second industrial revolution was to remove from the power source. So for steam production, or if you have some kind of other water-related power supply, you need to be near the river. Yeah, you need to have a lot of water. In case of electricity, you can move out of the source of the energy, so away from the source of the energy, and consume this energy. So that was the main benefit of the electricity, and having electrical wires which basically transfer energy from the power source to the consumer. And that is how Industry 2.0 appeared. So basically this is like a pure usage of the electricity in the factories. The next one is Industry 3.0. As you can see on this picture, we have a lot of machines which are called robots. But these machines are basically mechanisms which repeatedly do the same action. So they have some kind of programming inside, but they repeating the action. So basically they are eliminating the need for just boring human work. So people just do not like to do the same thing 24/7, and robots like it. So they created to do this. And now I have just little task for your observation. I will show you a small slice of the Industry 4.0 robot and try to memorize this picture and try to compare what is different in this Industry 4.0 robot in this video. Just a second. Okay, so by the way, it was one of our products which we deployed for our customer Beko. It's for their exhibition. We created this robot to advertise their new coffee machine. So basically, you saw this robot, and now you see these robots. What is the difference between those robots, Industry 3.0 and 4.0? To replace human? Complete, this is good wording, yes, close. What else? Look on these guys. What you don't see here, what you saw there. Sorry? It's anthropomorphic, good, but this one also kind of like, yeah, okay, more anthropomorphic, true. But this is not the main key. Has sense, but why does it have sense? Well, but this is like this is a vice versa relation. Why people give it senses? Actually, yeah, very good thoughts. So basically, senses were given to this robot just not to kill the humans. So basically, the difference between these robots, and that robot are these cages. Do you see these cages? So there is no humans there, no single soul. And in this case, we saw a lot of humans running around, and they are not afraid of this robot. They should probably, but they are not. So, and that is the difference of the Industry 4.0. So Industry 4.0 would be based on the collaborative robots, which would be working with humans side by side. That is a really huge improvement. So basically that is really a step forward. And that is the main interest for us, for everyone, for software engineers, because now robotics, we call it advanced robotics, because this robot is not that kind of limited in the only single program. In this example, actually it was. But in the Industry 4.0, idea is that the robot would be collaborating with humans or even helping human. For example, I saw example on one of the conferences, the robot and human, they are solving some kind of element, and whenever human feels fatigue or was tired, robot overtakes the whole load of the sawing on itself, and human was just directing the saw blade on a particular angle. So that is a really good example how robots can add up to us. And so the most kind of not worrying but screaming thing which I found is on the article which is devoted to the Industry 4.0, you cannot find a single word about robot. If you search by robot there in this article, which is few pages long, there is no robots there. But just a second, who would be doing all Industry 4.0 work? Not humans, not all these sensors. Basically, Industry 4.0 about like integrated ecosystem of the sensors and something who would be doing the work. And actually, this something are robots. And this is something which is like missing link on which currently all not industries, but advanced companies are working just to get these robots which can accommodate and can collaborate with humans in the new factories. So that's why having smart robots, having nice computer vision which allows you to omit human and recognize objects with which you are interacting is the next step, and we should be paying attention to that. But now I want to share my story which probably should inspire you in case if you want to take this route and become a robot engineer. So basically, there is one nice quote from Sir Richard Branson. You can read it. So basically, I took this route. So I was ordinary software engineer in Ukrainian IT, and I was interested in the robots, and I decided how I can learn about robots. And it was like genius idea, just go and build some robots in the international company. And so I get myself hired to the Shadow Robot company, and for 4 years I built different robots of different scales. But let me compare to what I heard today in this conference, like ideas. For example, we have user some kind of task from the customer. The customer wants to build a store which is selling socks. Web store which is selling socks. Typical use case. If I am engineer, Java engineer, for example, well, I'm just asking probably which server should we on which server should we build it on. For example, which kind of hardware should it be? Which kind of operating system do you want to run it on? And which browser to support? So it's very important things. And I understand how to split these requirements from the building shop to exactly technology stack, to exact technology stack. And now my first task, my first user story which I get on my new job was basically very simple. Her Majesty government is asking for bidders to build robot which would be picking strawberries. And that's it. Well, there were some technical specifications, but that was the main thing. And so basically that was my reaction. So how? Web browser? Which operating system? What? So, but of course, here I'm a little bit kind of exaggerating because before going to this robot route, of course, I use Google and search for how people are building robots. That was like obvious thing. How nowadays you solve complicated questions. You just Google it. And so basically I Google it and found out that there is ROS, such thing, which is like short for Robot Operating System, which is maintained by Open Robotics. The main aim of this system is basically to support development of the robots. Of course, it's not panacea, it's not silver bullet, but it's basically something on which you can start build your robots. And I'll show you how. But first, of course, a few robots which were built using ROS. So basically, they are building this kind of video every year for ROS birthday, and so you can see how many different applications are there. This is one of our robots. Yes. So basically, what is ROS? If to keep it short, as I promised, I will not give you any complicated details. Basically, you can perceive ROS as some kind of message queue, where you have loosely coupled nodes which are exchanging messages. Why is it done so? The main reason for that is robots 10 years ago, it was like more than 10 years ago, then they built the system, were completely unreliable. And imagine that you have a humanoid robot. You have legs and you have hands, and for example, your left arm stopped working. Some microcontroller just died, or a small computer there died. And if you don't have a loosely coupled system, well, probably your humanoid will just like crash completely. In case if you'll have just a decoupled system where just it's the simple node and this node died, you still have legs nodes, you have central node, which is like coordinated movement, for example. And so basically, in this case, robot will survive and can do even something. Yeah, so basically that is the main idea behind decoupling and using the message queue. In the ROS, so currently there is ROS number 2 in the way. Just to give you a scale and understanding of the seriousness of the framework, there is a technical steering committee where just major companies which want to play on the robotics market. These are Amazon, Google, after that Canonical, just maintainer of Ubuntu, Microsoft. They have their representatives there in the steering committees in order to draw it, to drive it to some usable thing for industry. So basically that is really a powerful thing. And also in the ROS 2.0 you have like multiple coordination nodes, or so-called masters. So in the ROS 0.1 you have one master, so single point of failure. In the ROS number 2 you have multiple, just for your knowledge. So and very quickly, how do you build a robot using ROS? So first of all, you need to draw how a robot will look like in the real world. For that purpose, you use computer-aided design. So CAD, you draw it in some kind of SolidWorks or FreeCAD, or now we have Onshape, which is online service. Onshape, by the way, is very interesting because they have it. It's open source. It's free for open source drawings, which might be really powerful, and we use it, by the way. The next thing which you need to define based on your CAD model is URDF, which is basically a universal robot definition format. There you give connections between nodes of the robot and also some physical properties and inertial physical properties of the body of the robot, which would be used for further calculations of the dynamics. And also you give obstacles, so you give kind of bounding body around your robot, which allows to calculate collisions. For example, if you have some kind of moving robot outside in the environment. So control, so you define controllers. How do you want to control the robot? Speed controller, position controller. After that, you define simulation. So very good thing which we heavily employed in the Shadow Robot company, in the ROS Ukraine community, is simulation. You don't need to have a real robot. You can simulate it, and remote community can drive and build robot. And as you can see, can do a lot of funny stuffs without just any kind of money spent. So it's really cool. And the last one is, of course, navigation. So it's like adding navigation stack to the simulated robot. There you can do some kind of high-level tasks of sending some high-level goals to the robot, like go from this room to room number 5, for example. But last but not least, of course, is the hardware. So, of course, robot is not only regular PCs or even just x86 PCs, but it's also microcontrollers where you implement control of low-level elements, where you implement interaction with the sensors. Although in the situation with simulation, you don't have to have that. Simulation will change this, and for example, 1 or 2 people can just work on the hardware while you would be working on the high-level algorithm, which is like a good benefit to everyone. And in case of the strawberries, unfortunately, I cannot show you any pictures because they were classified, which means like there were no public resources which I can show you. So, but I want to show you one of the latest products on which we have been working, and you probably recognize the guy. It was in Las Vegas. This picture was taken. This is teleoperation robot, which is one of the best in the world, we can guess. So first of all, Jeff Bezos is wearing special gloves, which is called haptics gloves. They do have tactile feedback on their fingertips. So basically, and if you pay attention to the robot fingertips, you will see that they are green. So here probably, yeah, I'll press to another buttons. Here you will see that there is like green color here on the fingertips. So this is one of the best tactile sensors which are currently available on the market, which is called Biotech from Syntech. And so basically, together all this cybernetical system, all this robot allows user to have the full presence on the remote location. So you can get touch, and Jeff Bezos said about this, it's weirdly natural. He described his experience interacting with this robot. And in the Wired magazine, it was article that the guy, from this magazine, the correspondent. So he basically were in the headquarters of the haptics company in San Francisco, and our robot were in London, and he were able to pick things and feel things in the distance. So it's basically like 5,000 kilometers, and he has the feel of touch, and he can manipulate objects. Of course, he has a camera, but he can feel objects in his hands. And basically, you can extrapolate that, and you can use it, for example, for Mars exploration. Of course, in the Mars exploration, you will have 20 minutes or so delay, so it's probably too much. But if you talk about near orbit, so if astronaut is in the orbit of the Mars, he doesn't or she doesn't have to kind of land on the Mars. They can manipulate objects from the orbit, which is like cheaper and healthier probably, because you don't have to kind of land there, and there's like higher level of radiation. Although, okay, well, radiation is like it's questionable where level of radiation is higher. But you can collaborate with some distant objects. The same applies to the nuclear kind of facilities, where you can decommission some dangerous, hazardous things without touching them. So that was a successful project, which I can show you. So yeah, and it was done using ROS. So basically, now I want to just to shed a little bit of light on the how to do things with the ROS. And for you, if you just regularly working with the common languages like Java, Python, C#, etc., how to try things without kind of spending much power and energy. So first of all, there is a ROS Ukraine community. We are currently working on the, guess what, telepresence robot. But the idea is, of course, a little bit different. So this telepresence robot, it's kind of avatar experience robot, which allows you to teleport to some kind of remote location, for example, Lviv National Gallery, and kind of explore the site without moving from your current location. So you basically need to have a VR set, so you can buy Google Cardboard, which is like $2. After that, you can have some kind of joystick and mobile phone, headphones, and a microphone. And you can connect to Wi-Fi and connect to the robot whenever in the world, and you can teleoperate this robot. So basically, yeah. But how have you managed to do it? Have you managed to build it without having actual robot available yet? So of course, this friendly whale did a lot of useful work. So how? So first of all, on this whale, we put all these IDEs, and especially this one was a 9. Have you heard about, who has heard about Cloud9 IDE? One person. So basically, Cloud9 company were recently acquired by Amazon. This is a web-based IDE, which basically allows you to edit and run code from the web browser. Of course, you should have access to file system, but basically it allows you, in case of Docker containers, what problem do we have? The problem is, how do you show UI to the customer? So because Docker container, for example, on Windows, on Linux, there are possibilities to share UI. In Windows, I haven't seen that. Maybe there is one, but I haven't. So, and for that purpose, Cloud9 is used. But also Gazebo, which is simulator, which you will see today, has a Gazebo web port, which allows to run Gazebo on the web. And hooray, we have web IDE, and we have web simulator interface, which allow us to have Docker container, which is nicely packed and placed on the Docker hub to be used by everyone, and you can do whatever you want with it. But moreover, this Docker container, we use it for continuous integration. So for example, if you want to test navigation algorithm with your robot, it's very simple. You build it, well, very simple. So you build in simulation some kind of room where this robot or environment, and say for robot to travel from point A to point B, and for example, there could be some kind of time limit during which the robot should travel. Or there should be some kind of impossible situation. In this case, you will test recovery behavior of the robot. So we heavily used continuous integration with the Dockers to run basically that on the Travis CI, on the Circle CI, on the Homebrew Jenkins. And moreover, we use Docker containers to deploy releases on the robots themselves, which allow us to have version software on the robot. So usually at universities, they are just deploying source code directly, and after that compile it, and after that fix it, and after that compile it again, and after that no one's knows where is the working code. So in this case, you will have like strictly versioned software which is deployed on the production robot. Okay, fun part. So now I was talking about a lot of things. Just let me show you how the things can work really simply. So first of all, this is my PowerShell. So I'm using Windows. And as you know, usually demos don't work. So don't worry, I have pictures of what should be after this demo. So in case if it doesn't work. So there is a I will show the slide with address of this resource. This is ROS Ukraine Robot repository, and there is special branch for Java, and there is documentation how to run this. So I'm just basically copying Docker instruction and pasting it, and in a second, hooray, Docker started. So now we will go to the browser and try to browse to the Cloud9 IDE, so which is on the port 8181 on the local host. Let's see. Unbelievably, it does work as well. So now let me increase a little bit font. So for people who would be looking afterwards, there is like special package called Leobot Java example, and Leobot Java, sorry. And basically in this package, there are two examples. So written on Java, yeah. I'll show you the most interesting part there, so don't worry. So, and basically you can reproduce this demo using the source code. You can play with the source code. First of all, I will use a special launch system which is there in the ROS. So it's called ROS launch, Leobot launch, Gazebo web, and I will pass the world file equals art gallery. Oh, wow. Okay. And now, oh, something happens. Good. What happens? I probably core dump. Cool. As I said, it was promised. Good. So let me restart it. I'll check. Yeah. The web launch. Okay. Fingers crossed. Good. Cool. Okay. So typical software engineer approach, just close and start it again, worked again. So, and now the simulator is running on the port 8282. Let me, minimize it. And what you will see here in a second and a half, in a little bit in a second. Okay, so I'll show you another room. So here, oh yeah, here it is. You will see here Lviv National Gallery itself. So this simulation was created by one of the ROS Ukraine participants. So he basically get to the Lviv National Gallery, took the fire evacuation plan, take a picture of it. And after that, take a picture of the majority of the objects of interest and build based on that simulation of the Lviv National Gallery. That's it. Well, it wasn't that simple because you understand, like, you need to just get every picture, put it on the wall, on precise place, etc. But now we can reuse this gallery multiple times. And now let's have a look on the code itself. Sorry about that. So code of it's called simple autopilot. I will skip not interesting places. The most interesting place here is this. So there is a publisher. I don't know if you can see it. Can you see it? Good. So there is a publisher which is publishing to the topic which is called KMD val. So it's like command velocity, and there is some kind of message type, which just doesn't matter in this point. And so basically here we get this new message, and we putting that to linear speed in the x direction pointing to the face of the robot, so in front of the robot. We're saying that robot should move with the speed 0.2 meter per second. And they should repeat 70 times with a thread sleep of the 1/4 of the second. And after that, we would be moving minus 0.2 meter per second. So we'll be moving backward. So let's try backwards. So let's try and start this example. So there is like, again, in the README file, there is document and code, and I place it there. Oh, sorry, it's blocked, Control V. Now it's not blocked. And now let's have a look on our robot. What's going on with the robot? And as you can see, we have robot there. And robot is moving forward. So robot, as you can see, robot is very simple, so we just use boxes for simplicity's sake. And robot moving backward. So as you can see from the high-level language as Java, because we have this like message queue and decoupled design, we simply can send commands. Of course, on Java you can do like more complicated logic, like state machine or some kind of cloud computing, etc., and sending this result to the robot. And for example, if you want to recognize a picture, if you have augmented reality and you want to provide user information about what is the picture about, who is the painter, so you can use cloud service to provide this extra information based on the information from the cameras. And now, as promised, there is another example. So another example is called crazy autopilot. And the only difference of this crazy autopilot is this line of code. Who knows what does it do? Sorry? Jump? Raise? No, it's not rising. Sorry? Rotate. It's rotating. So it's like, see here, there is a get angular. It's in context, it means like angular speed. So it's not linear, but it's angular. And so it means like around z-axis pointed upward in the robot. So rotate around z-axis. So robot, beside moving forward, would be just rotating. And let's have a look how it will look like. So here again you have example. Okay, crazy autopilot. Let's have a look. Oh no, it's already getting crazy. So basically, what is my point with the crazy autopilot, besides entertain you in this late hour of the conference, is to show you that expensive equipment, sometimes robots might cost like Ferrari car, literally like Ferrari car. So you can just break it in the simulation without any kind of consequences. If you're using Docker containers, you can reset up this simulation almost simultaneously. Oh, you can see. Oh, it's getting really bad. Oh, and you can see that this stuff might be really expensive. Oh, this is very bad view. So basically, having this like expensive equipment can be safe and can be tested. Oh, that's it. We get out of the art gallery. So it can be saved and can be tested even before we use it. And basically, we are using that whenever we're planning some trajectories, which we are, for example, using for offline replanning, because the robot might crash to the table, for example, or might do some damage. So yeah, so that is a very good example of what can be done. But moreover, I would like to show you just really quick, there is an interesting, I probably need to restart simulation. We also developed web console, which allows to control robot from the web browser. So you can see from the eyes of the robot and you can control it. So basically, this is basically a start design of this robot, which could be used remotely. This is just starting point. So I quickly will show it. And again, you can try it at home whenever you like. Just a second. Okay, let's start our gallery one more time. Okay, and now I will start another service, which is called ROS launch, robot launch. Web server launch. Okay, and so this web server actually allows us to, let me refresh it. This web server will allow us to, localhost, and it will remain on the port 8080. And soon you will see control panel. Yeah, so now you can see what robots see from the left eye. Not right, but left. And so you can control the head. See, now I'm rotating only head. So I'm not rotating the whole robot. I'm rotating only head. Just a second. So as you can see in simulation, there is a slight rotation of this, like two green dots are cameras, and this yellow thing is a kind of head simulation. So, and we can rotate it. But moreover, if you look up here, and if you want to play with virtual reality, we already have a virtual reality stub, which basically allows you to see from the left and right eye. And if you have a headset, you can basically put it on your head, and you will see like projection. Of course, it's not perfect. It should be kind of rounded, etc. So it's work need to be done, but it's already there. So if you want to experiment with it, so here it is. Play with it, break it. So you can, for example, try to. This is the driving option. So I am now driving the robot forward, and basically now I can do some damage. Okay. So, good. Let me finish simulation. Stop and stop. Let me switch to the demo. So, and now there are two pictures which I promised in case if demo will totally fail. So these are two pictures. Okay, so if you're interested, if what I showed to you looks something you want to play with, these are links to the main resources that I found useful. First one is an open source free book. Also, there is a nice book, Gentle Introduction to ROS. There is ROS tutorials for clear path robotics. ROS Wiki, which is not always good, nicely structured. This code, which you saw, branch F Java example, and also Docker image. So Docker image is ROS Ukraine Leobot Dev Java. So feel free to download it. Feel free to play with it. Yeah, it should be fun. And also, I would like to advertise the Facebook page of the ROS Ukraine community. If you want to see the latest updates of this work on this robot, or the latest updates from the ROS community, robot community, so feel free to add to this Facebook group, or you have some questions, you can find me there. Yeah, I'm available and I'm replying with a rather good rate, hopefully. Basically, yeah. So to summarize, robots are very important in our everyday life. If you turn around, even today, in this opening notes, you saw these kind of triangles which were dancing. So we can say that this is art robot. So art and robotics are getting also to the kind of common grounds, and it is to some extent art robot. So robot vacuum cleaners, robots which are kind of like flying around and doing some kind of mapping, etc. Autonomous cars are the same robots as well. So they are autonomous driving. This is like car as a robot. So, and if you want to keep up with the latest and the modern development trends, we have to look up to the robots, and ROS is one of the good starting points. So I just recommend you, everyone who want to look up on the robots, devote your time and check ROS, check simulations, and try to play with it. And thank you very much for your attention in this late evening hour. Maybe you have some questions. I will gladly answer.
Thanks for a nice presentation, by the way. Could you please show, like, I just couldn't understand, how do we bind this high level to some particular hardware? I mean, like, okay, you get some, so probably there is some configuration file which maps this ROS system to hardware, particular hardware.
Well, basically, if you talk about controlling the hardware,
yeah, so there is a robot which is going like one side to another side. So, okay, you build the robot, you use some hardware, right? So you deploy your ROS system into this. So, but I guess, I suppose there are different, those devices, there are a variety of devices, right? Which allows you to rotate, etc., right? So do they use some unified interface? Do they use some unified interface, or you should somehow implement binding? Like, I don't know.
Well, yeah, so there is a ROS control, for example, if you talk about controlling these devices, there is like unified interface, which is in case of the simulation, it's like substituted by the simulated part. And in case of the real hardware, you have to implement it yourself. For example, if you want to send command to the motor, you implement this part and implement communication with microcontroller, which actually moves this motor. So you have to implement that.
So you implement this binding, actually?
Yes, okay. Yes. Anyone else? Okay, in this case, thank you very much and have a nice conference.